Well, good morning, everybody. Welcome to day 3 of the Advent of Code. We are off today, getting ready to head into the jungle. We are getting our rucksacks packed, and it looks like the elves have already got an issue that they need help solving today. You can see here, each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves have made a list of all of the items currently in each rucksack, which is our puzzle input, but they need our help in finding the errors. Every item type is identified by a single lowercase or uppercase letter, that is A and capital A refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represents items in the second compartment. So for example, if we take this rucksack right here, and we split it in half right down the middle, we get to see that the first compartment contains the items here, while the second compartment contains the items here. And the only item type that appears in both compartments is the lowercase p. To help prioritize our item rearrangement, every item type can be converted into a priority. Lowercase items, types A through Z, have priorities 1 through 26, and uppercase items, types A through Z, have priorities 27 through 52. We need to find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? Here we are back over in our VS Code on our day3.py with our input file already copy pasted in. So let's go ahead and start defining our parser for the day. Of course, we want to go ahead and open up our input3.txt file as our file pointer. Alright, so we're going to be using list slices to get the first halves and second halves of these lines for our rucksacks. Alrighty, and there you go. We'll see that by doing that, we now have it split up into 2 separate strings that we can use to represent each compartment. One interesting thing here is you'll notice this -1 up here. Note that that's specifically because each line is going to have a new line at the end of it, which we do not want to include. Alrighty, our next priority from that is going to be to define a function that will find our priorities. Remember, we have a specific way that we want these rucksacks to be sorted based on what letter we're looking at a time. For our letters, we have the priorities given so that lowercase letters are given values 1 through 26, and uppercase letters are given the values 27 through 52. So we'll check if the letter is lower. And if it is, we will return the ASCII value of itself minus the ASCII value of the letter lowercase a plus 1, because that would equal 0. And running that, we'll see that a value of a gives us 1, while a value of z gives us 26. So now we'll go to our else right here and return the ASCII of the letter minus the ASCII of capital letter A plus 27. And checking it down here, we should see a value of 27. And trying it with the letter Z, we should have a value of 52. Very good, very good. Now we can simplify this up a little bit up here. Alright, so we've simplified this a bit up here. Now we're not having to have all that messy if-else. We've just got a couple little tuples here with the values, and then using the Boolean of L.isLower to get the value out of there for the subtraction or the addition here. So now we can actually return this as a lambda instead. Perfect. There we go. So now that we have a way to find our priorities, we will move down here and start creating our process for the day, which of course will take in our rucksacks. Okay, now within our process, we're going to be taking, once again, the sum of a list comprehension. Now within this list comprehension, we need to find the common values of the first and second compartments of each backpack. So of course, we're going to have X for sack in rucksacks. Now today, that value of X is going to be the common letter, which means we can go ahead and wrap it in our priorities function. And I think we're going to try to use the set objects capabilities today for this. Let's bounce over to testing and see what we can do with this. Let's suppose we have two words. Word 1 equal to 1 and word 2 equal to 2, but as strings. Now what happens when we print the set of word 1 on the intersection of word 2? If we look down here, we can see that we have a single value, which is that O, because that is the only value in common between these two strings. So now if we bounce back over here, we can take the set of the first value in sac and intersection it with the second value in sac. And now if we print our process on the value gotten from parser, let's see what we end up with. Okay, so here we have a quick little issue. We were giving ord a set instead of a string, which is no good, so let's see if we can just do a quick little conversion here. We'll use .join on this to convert to a string. Alright, now let's see if we run this, what value we get, and we get 7,568. If we head back over to the advent of code and we put this into there, 7,568, and submit, we get 1 gold star closer to collecting enough star fruit. Let us continue to part 2. Okay, as we finish identifying the misplaced items, the elves come to us with another issue. For safety, the elves are divided into groups of 3. Each elf carries a badge that identifies their group. For efficiency, within each group of the 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, and then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badge. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, and the second group's rucksacks are the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is lowercase r, so that must be their badge, and in the second group, the badge item type must be Z. Priorities for this items must still be found to organize the sticker attachment efforts. All we need to do now is instead have it so that every set of 3 lines is going to be a set of rucksacks, and then we just need to do the same thing to find out what's the common item between all 3 rows. I think today we will go ahead and define a second parser, which we'll call parser 2. So here we are. We've started out with getting our lines with read lines. Then we've created a result list to hold all of our sublists or groups of packs. Now we're going to for loop through our lines and start sorting them out. Now for starters, we want to have a condition so that if I modulus 3 is equal to 0, or we could say if not I modulus 3, then we want to append an empty list to result. Then down here, we simply want to append I to the last value in result. And now if we return result, let's see how that comes out. Whoops, scratch that. We don't want to append I. We want to append lines I. There we go, like that. Now the one thing we still need to do is strip that new line again. Now we are ready to begin writing out process 2, which we'll take in groups this time. And other than that, should be fairly simple as the priorities have stayed the same. We just have 3 sets that we need to connect instead of only 1. So we're going to return the sum of another list comprehension with a dot join on the set of group 0. But this time for our intersection, we have 2 values we want to compare instead of only 1. Both 1 and 2 for group in groups. Let us see what value that gives us. We get ourselves 2,780. Which, if we take that back over here, let's see if we got that right. Moment of truth here. That's the right answer. 1 gold star closer to collecting enough star fruit. And we are done for the day. Woohoo! Well, I thought that was a pretty fun day 3, didn't y'all? As always, I'll be back tomorrow with more. I'm going to be posting this on my GitHub, which I will have a link to down in the description below. If y'all enjoyed watching, please consider leaving a like or a comment. It would mean the world to me. Thank y'all so much for watching, and until tomorrow, y'all take care.